So that was an example of calculating the empirical formula. How would we figure out what the molecular formula is? Well, we mentioned before, the molecular formula is always a whole number multiple of the empirical formula. We just need to figure out what that whole number is. So if we have an example of an empirical formula of CH2O, to find the molecular formula, we just need to figure out what number to multiply this by. And to figure that out, we need one more piece of information. We need the molar mass of a compound. And so experimentally, we saw an example of how you can decompose a compound into its elements to find the masses of the elements. We're also in lab, we're going to combine elements to form a compound, which will also give us the information to calculate an empirical formula. How would you find the molar mass of a compound whose formula you don't know? There's an instrument called a mass spectrometer that will give you the molar mass of the compound. And so experimentally, that's how that would be done. You would do another test on this very large, expensive piece of equipment to get the molar mass. So the molar mass tells you the mass of 1 mole of this. You know the formula for the empirical formula. And so if we take the mass of the actual molecule and divide by the mass of our empirical formula, that's going to tell us how many times this fits into the molecular formula. Does that make sense? Maybe it'll make more sense when we do an example. When we find that n, then we just multiply all the subscripts in the empirical formula by that number n. So here's an example. A compound containing phosphorus and oxygen has a molar mass of 219.9 grams per mole and an empirical formula of P2O3. Determine its molecular formula. So P2O3, that has already been determined for us. What's the molar mass of P2O3? Well, 2 times the mass of phosphorus plus 3 times the mass of oxygen. $109.94. Is that the same as the molar mass of the actual compound? No, it isn't. This one's bigger. That means that the molecular formula is bigger than this. It's multiplied by some whole number. Is it twice as big? Is it 3 times as big? There's an easy way to figure it out. You can kind of look at those numbers and guess that it's going to be 2. But if you take the actual molar mass and divide it by this, that'll tell you how many times bigger it is. So we'll take the actual molar mass, 219.9, and that has to be given to you in a problem. 219.9, and we're going to divide by the molar mass of the empirical formula. You've got the empirical formula, you calculate that the way you would calculate any molar mass. So we got 219.9 divided by 109.94, and the calculator shows me 2.000181917. That's 2. Okay, that's really close to 2. That tells us that there are 2 of these in the actual molecular formula. So we take our empirical formula and we multiply it by 2. Now we're not going to leave it like that because that's not how we write formulas. We're going to multiply it through. We have P4O6 is the molecular formula for that compound. And you could check that by calculating the molar mass of this compound. 4 times the mass of phosphorus plus 6 times the mass of oxygen would give you something very close to 219.9. Question?
So if that came out to 2.5 something, we multiply by 3?
If it came out to 2.5, they set up the problem badly. Yeah.
If
If you were doing an experiment and your data came out like that, where the ratio here was 2.5, that means there's a problem. Something's wrong. Your molar mass, actual molar mass is wrong, or you calculated the empirical formula wrong, or you're doing a calculation wrong. There's no fixing something like that.
So usually when we go to do molecular formulas, they're gonna come out, if you do it correctly with a whole number with
Yeah.
that.
These ratios are going to come out very close to a whole number. Very close. Yep. Yeah. When we're calculating empirical formulas, that could be all over the place. And in lab today, some of you will do the procedure and get really good results and come up with the correct formula. And some of you, I don't know what happens. There's gremlins. They do things. They do things when we're not looking. Your data will come out really, really funky, and you'll end up with an incorrect formula. And that just says, okay, well, you were sloppy with your experimental technique. What I'm most concerned about, though, is can you do the calculation? Any other questions? So there we've got the end of chapter 6, and we've got our review slides.